Okay, so last time we talked about how to factor polynomials in the form x squared plus bx plus c, where the leading coefficient was 1. Today we're going to talk about how we factor polynomials where the leading coefficient is something other than 1. In other words, there's a number in front of x squared, doesn't have a 1. Okay, so that's what we're going to try to do. Before we get going, how many Sour Patch Kids are in this bag? All right, so last time we saw a polynomial. We learned how to factor it, so it looks like this. It's a little trickier if the leading coefficient is not 1. You've got, like in this case, an 8 in front. How do I go from this back to here? Well, you can kind of see 2x and 4x. Okay, that makes some sense. 4 and 5, that makes some sense. But how is that going to give me this term in the middle? And that's a little trickier to figure out. So I used to go through and teach this in a method that our Algebra 2 book recommends. You try to find numbers that multiply to be a, they go here. Numbers that multiply to be c, they go here and here. But the sum of the outer and inner products has to equal the b term, and that gets super complicated, so it doesn't really work. So really very easily you can get it to work. You usually have to make a chart, you go through this whole mess, and you can see it gets kind of messy. So I just thought, oh, there's got to be a different way to do this that seems a little bit more manageable. And there are a bunch of different ways, but I found a new way to do this that I really like, and it's kind of a ninja trick. And math tricks are not always the best to remember, but I think this one might be worth it. So here's how it works. And yes, it's weird. Now notice the answer to this is the same polynomial as right here, 2x squared plus 17x plus 21. And the answer is x plus 7 and 2x plus 3. Okay. So how does this work? What you do is you start by writing your polynomial without your a. So it would be x squared plus 17x. And then you don't write anything after that. You put a blank. And what's going to go in the blank is your a times your c. In this case, this is my a, this is my c. So 2 times 21 will go here. That's positive 42. Okay. And now, because it has a leading coefficient of 1, we can factor it in the way that we learned last time. X here, x here. And we say, what are two numbers that multiply to be 42 but add up to be 17? And you can go through these. These are a little bit trickier ones. It's 3 and 14. You would eventually get there. That's how you do that, just like we learned last time. All right, now, once you've done that, then the next thing, and this is where it gets a little weird. This, if you multiply this out, you will get this, not this. So that's clearly not the same, right? So there's something still missing. What we need to do now is we're going to take this 2 and we're going to put it underneath each of these and divide them. Okay, so now at this point you want to reduce these fractions. Okay, so 3 over 2 is reduced already. It stays 3 over 2. This one, not reduced, that would be 7. Okay. Now, if you have any remaining denominators, this is a denominator, you move them in front of the x. Okay? So it's kind of weird. I got a denominator of 2. It gets moved in front of the x. And then that 3 stays there. So this will be 2x plus 3 and x plus 7. Now, if you multiplied this, you would get this back. So that right here is the factored form of 2x squared plus 17x plus 21. Notice, same answer that we had right here. They're just reversed. Doesn't matter. It's multiplication. Doesn't matter which order they're in. So this seems weird at first, but trust me, it's significantly faster and easier than all these other methods. So this is the one I'm going to teach you. Okay, so here are the steps. Once again, write it x squared plus bx, and notice you're writing it without the a first. Then inside the blank, you're going to go a times c is going to go in that blank. You're going to factor the polynomial. And then you're going to take your leading coefficient and you're going to put it underneath both of those guys right there. And then you'll reduce. Make sure you don't forget this step. And lastly, if there are any remaining denominators, you move them in front of the x. Okay, so we're going to try this now a few times, see if we've got it. Okay, so I'm going to follow these steps here on the right. Let's switch colors. How about that? And so I'm going to write x squared plus 19x blank. Okay, so notice again, no 6 in front. And now I'm going to put what goes in this blank here is a times c. My a is 6, my c is 10. So it's 6 times 10, that's 60. So I'm going to write plus 60. Okay, so that's step 2. Step 3 says to factor this polynomial now that it has a leading coefficient of 1. I can do that. Two numbers that multiply to be 60 but add up to be 19. You might play around a little bit with this, but you'll eventually run across 4 and 15. Okay, now my leading coefficient is 6. Now this is going to go here and here. Okay, so divide both by your a value. Okay, cool. Now I'm going to reduce this fraction for both of these. So again, if you're not good with reducing fractions, use your calculator. Go to the math frickin' frac. I'll show you how to do that again if you're not good with that. You've got 4 divided by... Oh, let me pull it up here. So if you go 4 divided by 6, just press the math button, press enter a couple times, and you can see it says 2/3. Okay, that's how you reduce fractions. If you're not great at it, it's a quick way to do it. This is 2/3, and then I would reduce this fraction. If you do that, you would get 5/2. Okay, now both of these have a remaining denominator after I reduced. Don't forget to reduce. That was what we just did. That's a huge step. Now, I'm going to move this 3 in front of this x. So this would be 3x plus 2. And then I'm going to move this 2 in front of the x, so that would be 2x plus 5. So the denominator moves in front of the x after that. And that is your factored form. And that's really it. Okay? So we're going to practice this a couple more times. Now we're going to throw in a few different things like, what if there's negatives or something like that? So, okay, again, x squared minus 15x, and put the blank. Inside the blank is going to go a times c, 9 times 4. So that's positive 36. If like the 4 was negative, then you would have negative 36 there. So just be aware of the signs. I'm going to factor this. Two numbers that multiply to be positive 36 but add up to be negative 15. It's going to have to be negative 3 and negative 12. Okay. Now I'm going to put my a, which is 9, that's going to go underneath here and underneath here. Okay, now it says to reduce. So we'll have, this is 1/3, and this is 4/3. Okay, I do have some remaining denominators, so I'm going to move them in front of the x. 3x minus 1 and 3x minus 4 as the factored form of 9x squared minus 15x plus 4. Okay. Weird, yes, but also pretty awesome. Trust me, this is one of the best ways to factor these kinds of polynomials, I think. Okay. Let's try this again. Now this one's got multiple negatives, so let's see. We've got x squared minus 15x blank. Inside the blank, I'm putting 4 times negative 4, which is negative 16, so I'm going to write minus 16. Factor this polynomial. All right, two numbers that multiply to be negative 16, but add up to be negative 15 would be negative 16 and positive 1. Okay, now I have a 4 in front, so I'm going to go divided by 4, divided by 4. Reduce, so I get x minus 4, and 1/4 is already reduced. Okay. This one doesn't have any denominator remaining, and now I can move this in front, right? So this will be 4x plus 1. And now that's factored. Okay, that is how you factor polynomials in the form ax squared plus bx plus c. Okay, pretty slick. So what I'd like you to do is try this assignment, write it into your planner, check it off when you complete it. All right, see ya.